This apparatus is series and parallel pump apparatus. This apparatus is used to investigate the function of a centrifugal pump when the pumps are operating in series and when the pumps are operating in parallel. As you know that if we connect the pumps in series, it increases their head so that we can flow the water to a longer distance than the pump's single rating. In case of parallel, if we want to double the discharge or if we want to have a more flow rate, then we operate the pumps in the parallel. If you go to these three equipments, this equipment consists of two centrifugal pumps having a capacity of 0.5 HPEs. This is one centrifugal pump, pump number 1, and this is pump number 2, and the both pumps are similar in characteristics, and the capacity of the both pumps are 0.5 HPEs, that is 0.375 kilovolt. Now if we consider the working, so this is the sum tank with which two pumps are connected. The first pump is connected to this line and the second pump is connected to this line. Each pump is connected with suction gauge and the discharge gauge. Now you can say each pump has two gauges. One is connected at the suction point and other is connected at its discharge point. Similarly, on the second pump, it also has the two pressure gauges at the suction point and at the discharge point. And where both two these lines are, there's a third one gauge also, which tells you the discharge pressure of the main discharge line. After that comes this flow sensor, which tells you the flow rate of the main discharge line, and that comes a valve, control valve, which can create the different heads. And this line goes back to the sum tank. This is the control panel. This control panel consists of three switches for mains, on-off switch for pump 1, on-off switch for pump 2, and this is the indicator for indicating the flow rate in liters per hour, LP. Now, if you see these separators consist of several ports. To make the arrangement, either you want to operate the pump in series, in parallel, or you want to operate the pump as a single unit. If you want to know the characteristics of a single pump, we have to consider only this line. So for that, if you are calculating the single characteristics, you have to close this line. This will be closed. This also will be closed, and this valve should also be closed. So this valve number 1, valve number 2, and valve number 3 will be closed. The only line remains is this. It takes this pump will take the water from this line. This will be the suction line, and then the line goes to the discharge back to the tank. If you want to operate this unit as a parallel, both pumps operates in parallel, then suction line of the pump 1 should be opened, suction line of the pump 2 should also be opened, this valve will remain closed, and this line should also be open. Now our flow rate will be like this. This will go like this into this. Other line will go from there and this. So both the discharges will meet at here, and it will result in doubling the discharge, or the discharge will be more as compared to the single. When you want to operate in the series, in that case, you have to close this valve. This valve should be closed. This valve should be open. The line goes from here. This valve should also be closed. So our line will be like this. This should also be open. Now, if you see these pumps are in series. This pump will take the water from this tank, and this pump will take the water from this pump. So this gauge will now act as a discharge gauge. Earlier it was a suction gauge when it was operating as single or parallel unit, but now this gauge will act as a discharge gauge for this gauge. So this will be your suction gauge. It will give you the suction pressure. You can change the suction pressure with the help of this valve, and then this will tell you the discharge. Again, this gauge will becomes as a discharge. This also give you the discharge. This also will give the discharge, and this also give the discharge. Similarly to same to this one. And from here you can change the head, as we know. Now, how to operate? Suppose you want to operate the pump in single unit. So this will be closed, this will be closed, this will be closed, and this will be open. And now I will switch on the mains. You will see here the flow. Then I will switch on the pump 2. As I switch on the pump 2, you will see here, this is showing the flow rate. We will wait for some few seconds to get it stabilized. Now it is stabilized, the flow rate is 1936. The suction pressure is minus 0.01 and the discharge pressure is, as you can see, 1, 2, 3, 4, 5.5 kg per centimeter square. And this should also showing the same, similar to near to 0.5 centimeter square. And as I close the valve, to half, you can see the discharge pressure is, discharge head is increasing. So in this way I can vary the discharge, and as I am varying the discharge, you can see the flow rate is also changing. As I am increasing the head, the flow rate is decreasing. As I decrease the head, the flow rate is increasing. Now I will see what happens when these pumps are in parallel. What happened with the discharge? What happened with the heads of pumps? What happened with the discharge, main discharge? So to make it parallel again, I will make this valve open. Also I will make this valve open, and I will switch on the pump number 1 also. As you can see, the discharge earlier it was 1900 LPH. The discharge has increased to 3129 LPH. So when the pumps are acting in parallel, head almost remains the same. You can see head remains the same, but our discharge has been increased. You can see the main discharge line is 1. The head of this discharge line is also near to 1. This discharge line is also near to 1. So the head of both the pumps are same, but what happened is the discharge has increased. Now I am shifting this configuration to series. When I shift this configuration to series, I will make this line close, this line also closed, and make this line open. Now what happens? So you can see here is showing the discharge. The discharge of this pump is 0.4. But you can see the discharge of this pump will be increased, and it is increased to 0.6 in comparison to this, and this will also act as a discharge gauge. And as you can see, the flow rate remains almost the same, 2169. As you increase the head, you can see there is not much difference, but the head is increased. So you can know the characteristics by taking the different flow rates at different heads, and can demonstrate the students about how the centrifugal pumps act when they are operating in series connection, they are operating in parallel connection, and when they are operating as a single unit. Thank you.